What if everything we've been taught about planets, stars, and the universe itself is only part of the story? For centuries, Earth has been held up as the gold standard, the rare world that somehow ended up with the perfect mix of water, atmosphere, and chemistry to make life possible. Textbooks painted a picture of a quiet, predictable universe where planets form the same way, stars live and die on a schedule, and Earth just happened to be lucky. But what if that picture is wrong? What if the universe is far stranger, far more violent, and far more unpredictable than we ever imagined? In just the last few years, the James Webb Space Telescope has shattered old ideas and revealed a cosmos filled with worlds and phenomena that don't just bend the rules, they break them entirely. Planets that glow like molten metal yet cling to atmospheres they shouldn't have. Ancient travelers drifting through our solar system that predate Earth itself. Entire galaxies being ripped apart before our eyes, spewing streams of stars like cosmic jellyfish. Even mysterious red dots scattered across the earliest universe, glowing so brightly that scientists can't even decide what they are. Each discovery forces us to ask unsettling questions. Is Earth really unique, or just one odd case among countless possibilities? Could life thrive in conditions so alien we can barely imagine them? And most importantly, what else is out there, waiting to overturn everything we think we know? This isn't just about astronomy, it's about rewriting humanity's place in the universe. And as the evidence piles up, one truth becomes impossible to ignore. The cosmos is full of secrets, and we are only beginning to uncover them. For decades, the story of how planets form seemed settled. A young star ignites, surrounded by a swirling disk of dust and gas. Gravity pulls the material together. Dust becomes pebbles, pebbles become rocks, and eventually those rocks grow into full planets. The recipe always looked the same. Start with silicates, metals and ice. Sprinkle in a little water, and given enough time, you get a rocky world like Earth. The logic seemed airtight, because the planets in our own solar system fit the model neatly. Mercury, Venus, Earth and Mars formed close to the Sun from heavy elements, while the outer planets gathered ice and gas to become giants. For years, astronomers assumed that was the universal pattern, the cosmic assembly line producing predictable results. But now, new discoveries are exposing flaws in this comforting picture. Instead of order and predictability, the universe is showing us chaos, creativity, and rules being rewritten before our eyes. The James Webb Space Telescope has delivered some of the most shocking revelations. When it turned its gaze toward young planetary systems, it didn't find the neat chemistry scientists expected. Instead, it uncovered planets forming in regions dominated not by water and silicate-rich dust, but by carbon dioxide. That simple molecule, so central to our lives here on Earth, was never supposed to dominate the building blocks of a planet. Yet Webb has shown that some worlds may emerge in environments where carbon dioxide, not water, is the main ingredient. And that flips everything we thought we knew about planetary formation. Because if worlds can grow up in those alien conditions, then Earth is no longer the blueprint. It's just one of many possible outcomes. The implications are staggering. For decades, astronomers assumed that water was the non-negotiable key to habitability. No water, no life. But what if entire planets form with barely any water at all? Could life still emerge in a carbon dioxide-dominated environment, thriving on chemistry we don't yet understand? Or are those worlds doomed to sterility, barren landscapes without oceans, rivers or rain? If the universe produces billions of such planets, then maybe our version of life, water-based oxygen breathing, is the exception, not the rule. That possibility shakes the foundation of our search for life beyond Earth. We may be looking for reflections of ourselves when the cosmos is filled with forms so alien they would defy our imagination. This discovery also changes how we see Earth. For years, our planet has been framed as the rare, just right world in the so-called Goldilocks zone, perfectly balanced between too hot and too cold, with the right chemistry for life. But if planets can form under conditions utterly unlike ours, then maybe Earth is not the inevitable outcome of cosmic processes, but an outlier, a strange accident in a universe filled with worlds that look nothing like it. That realization is both humbling and unsettling. It means we can no longer assume that we are the standard by which other planets should be measured. The story gets even stranger when you consider how quickly these alien worlds appear to form. Traditional models suggested that planets take tens of millions of years to assemble, slowly gathering material from their disks. But Webb has observed young stars with planetary building blocks already in place. As though worlds were forming at breakneck speed, some disks seem to skip steps entirely, producing gas giants in regions where only rocky planets should exist. Others appear to run out of material halfway through, leaving behind stunted worlds with bizarre chemistries. Far from a predictable process, planetary formation now looks like a cosmic experiment, producing a chaotic mix of outcomes rather than a standard template. And if planetary formation is more chaotic than we thought, then our search for life must expand beyond narrow expectations. For years, exoplanet hunters focused on Earth-like worlds, rocky, water-rich, orbiting sun-like stars. But what if life thrives in environments that don't match Earth at all? Carbon dioxide worlds, hydrogen-rich giants, or even planets with molten metal rain might host forms of chemistry that are alive in ways we don't yet recognize. By limiting ourselves to searching for Earth clones, we might be ignoring the majority of life-bearing worlds. The cosmos may be teeming with biology, but so alien we would not even recognize it. These revelations also raise another haunting possibility. If Earth is an outlier, then life here might be far rarer than we hope. We often comfort ourselves with the belief that the universe must be full of life, given the number of stars and planets. But what if our chemistry, our oceans, our balance of gases, is the product of an extraordinary accident, one that almost never happens? If that is true, then humanity may be among the rarest phenomena in the cosmos, a fragile spark in a universe filled with worlds that could never support us. The thought is chilling, but it forces us to appreciate just how unlikely and precious life on Earth might truly be. Yet there is another side to the story. The more diverse planetary formation becomes, the more possible paths to life emerge. If carbon dioxide worlds can exist, perhaps life there would not need water, but could rely on carbon chemistry we don't yet understand. If planets form faster than we thought, then perhaps civilizations can rise earlier, giving them head starts of millions of years. And if planetary formation is not bound by neat rules, then maybe the universe is far more fertile than we ever imagined. Instead of being alone, we may be surrounded by life, but life so different from us that it seems invisible until we learn how to see it. At the heart of all this is one sobering truth: the universe is not following our rules. The neat diagrams in textbooks, the simple models of disks and dust, are breaking under the weight of new evidence. The cosmos is revealing itself to be stranger, faster, and more diverse than we ever dared to imagine. And every new discovery raises fresh questions. What other kinds of planets are out there? What chemistries do they carry? What forms of life might they support? And if Earth is not the standard, then what does that say about us? Are we the lucky exception, or just one experiment among billions? As the James Webb Space Telescope continues to peer deeper into the universe, the story of planetary formation will only grow stranger. But one lesson is already clear: the foundations we thought were solid are cracking, and in their place is a new vision of the cosmos, one filled with worlds that should not exist, yet do. And if planets themselves can defy the rules, what else might the universe be hiding, waiting to overturn everything we think we know? Among the strangest revelations of the new era of astronomy is a world so bizarre it almost seems designed to break our understanding of what a planet can be. Its name is 55 Cancri, though some call it the Hell Planet, and for good reason. It orbits a star about 40 light-years from Earth, but it's no ordinary orbit. This world circles its star so closely that a single year there lasts less than 8. The star's relentless heat scorches the planet to temperatures above 4,000 degrees Fahrenheit, hotter than molten metal, hot enough to vaporize rock itself. By all logic, a planet that extreme shouldn't even exist, let alone maintain an atmosphere. Yet 55 Cancri has defied every expectation, forcing astronomers to rethink everything they thought they knew about planetary survival. The surface of 55 Cancri is believed to be a literal ocean of lava. Imagine entire continents of rock melted down into rivers and seas of glowing magma, constantly shifting and bubbling under an alien sky. Winds scream across this inferno, moving vaporized rock particles in storms fiercer than any hurricane on Earth. It is a world not of water but of fire, where landscapes are liquid and the air is thick with the haze of evaporated minerals. In a sense, it's a vision of a planet still in the throes of its birth, but it is billions of years old, locked in a fiery standoff with its star. Scientists initially assumed that such extreme conditions would strip away any atmosphere in a matter of days. So, the radiation, the gravity, the constant tidal forces, it should have left the planet a bare, airless husk. But Webb's instruments revealed something no one expected. 55 Cancri air somehow clings to an atmosphere. The composition of that atmosphere is unlike anything we've seen before. Instead of nitrogen and oxygen like Earth or hydrogen and helium like Jupiter, it may be made of carbon dioxide, carbon monoxide, or even vaporized silicates. Essentially a rock-based atmosphere that continually bubbles up from the molten surface. This means the planet isn't just holding on to its atmosphere, it's regenerating it, bleeding gases from its fiery core into the sky in a never-ending cycle. The planet's very geology is alive in its skies, creating weather systems more alien than science fiction could dream up. What's even more puzzling is how stable the planet seems to be. In models, such extreme conditions should create chaos, tearing apart the atmosphere, boiling away surface layers, and leaving nothing but bare rock. Yet 55 Cancri air continues to orbit, continues to grow, continues to rebuild its strange gaseous shroud. It suggests that planets may be far more resilient than we once believed. Atmospheres once thought fragile and temporary might endure even in environments that seem impossible. And if an atmosphere can survive on a world like this, what other extremes might be possible across the galaxy? Some astronomers even speculate that 55 Cancri air might once have been Earth-like. Billions of years ago, it could have had oceans, continents, and a stable climate before migrating too close to its star. Over time, the heat boiled its oceans away, stripped its atmosphere, and melted its surface into a molten wasteland. If that's true, then 55 Cancri air is not just a scientific oddity, it's a chilling preview of what could happen to Earth in the far future. Our planet depends on a delicate balance of distance, atmosphere, and geology. A shift in any one of those variables could transform it into a hostile wasteland. 55 Cancri air stands as a cosmic warning of how fragile habitability truly is. But the mystery doesn't end there. Observations show that the planet might not even have a uniform surface. On Earth, the moon always shows the same face, locked by tidal forces. Similarly, 55 Cancri air is tidally locked, with one side always facing its star and the other always in darkness. One side is a permanent day, the other an eternal night. Scientists expected the day side to be far hotter than the night side, but data suggests something strange. Heat appears to be distributed more evenly than it should. That means powerful winds or even magma flows could be moving energy around the planet, creating a balance we don't yet understand. Imagine rivers of lava stretching from the day side to the night side, cooling, then cycling back in an endless loop. It's a planet-sized engine, a machine of fire and rock, running non-stop under the brutal glare of its sun. The very existence of 55 Cancri air challenges the way we search for life. Traditionally, we look for Earth-like planets, temperate, water-rich, orbiting in the so-called Goldilocks zone. But what if life doesn't require those conditions? What if it can adapt to extremes we'd never expect? On Earth, life has been found thriving in boiling hydrothermal vents, in acidic pools, even in radioactive waste. Extremophiles prove that biology is endlessly inventive. If life can exist in those extremes here, could it exist in some unimaginable form on a world like 55 Cancri air? Maybe not as we know it, but perhaps as something unrecognizable, something forged in fire rather than water. To dismiss it outright is to underestimate the adaptability of the cosmos. This planet also raises deeper philosophical questions. Why do such extreme worlds exist at all? If planetary formation were as neat and orderly as we once thought, there should be boundary zones where rocky planets cannot survive. Yet 55 Cancri air and others like it prove those boundaries are illusions. Planets form and persist in places that should be impossible, rewriting the rules of astrophysics. It suggests that the universe is less a machine and more an artist, experimenting with wild variations, pushing the boundaries of possibility. In that sense, 55 Cancri air is not a mistake. It is part of a cosmic pattern we are only beginning to glimpse. For humanity, discoveries like this change the narrative. Instead of seeing Earth as the inevitable product of planetary evolution, we now see it as one among countless variations, some serene, others terrifying. 55 Cancri air reminds us that nature is not bound by our expectations. It creates worlds that defy logic, worlds that challenge the imagination, worlds that force us to ask, what else is out there? waiting to break our rules. If a planet made of fire and storms can cling to life in its skies, then perhaps the universe is stranger and more alive than we ever dared to hope. And yet, the most haunting part of 55 Cancria is how familiar it feels in its strangeness. A world that may once have been Earth-like, transformed into a burning sphere by forces beyond its control. A world that clings to survival even as it is boiled, battered and reshaped. A world that should not exist, but does. It's easy to think of it as alien, but perhaps it is a mirror showing us what happens when balance is lost, when the delicate threads of habitability are pulled apart. In its molten oceans and vaporized skies, we glimpse both the resilience of planets and the fragility of life. And in that glimpse lies a truth we cannot ignore. The universe is not built for comfort, it is built for survival, and survival takes forms we are only beginning to imagine. In 2019, astronomers caught sight of something drifting through the solar system that seemed to defy explanation. It wasn't a planet, not a star, not even a typical comet or asteroid. It was a fragment from a place older than Earth, older even than the Sun itself. Its name was 3I Telis, and the more scientists studied it, the more unsettling it became. At roughly 7 billion years old, this object was a relic from a time before our solar system existed, a wandering survivor from a long-dead star system that collapsed billions of years ago. In other words, it was older than home itself, a messenger from a forgotten age of the universe, passing silently through our neighborhood before vanishing again into the black. Think about what that means. Earth is about 4.5 billion years old. The Sun is around the same age, but 3I predates both by billions of years. It formed in a system that lived, evolved and died long before our world ever began. The dust that eventually built Earth didn't even exist yet, when 3I was already orbiting some distant star. That star eventually reached the end of its life, perhaps exploding in a supernova or slowly collapsing into a white dwarf. Its planetary system was ripped apart, flinging debris into interstellar space. For billions of years, fragments like 3I wandered the galaxy, silent travelers carrying with them chemical fingerprints of their dead home. To stumble upon one is like finding a fossil not just older than humanity but older than Earth itself. What makes objects like 3I so extraordinary is how they preserve a kind of cosmic memory. Locked inside its ices and dust are the elements and compounds from the ancient system it once belonged to. Studying it is like opening a time capsule, sealed billions of years ago, showing us what worlds looked like before ours existed. These wanderers remind us that the universe is not just about creation, but about destruction and survival. Stars are born and die, planets form and shatter, systems rise and collapse, and yet fragments endure, drifting endlessly, carrying whispers of histories long erased. 3I wasn't the first interstellar visitor we've encountered. In 2017, astronomers discovered Oumuamua, a strange elongated object, tumbling through space at incredible speed. It too was from beyond the solar system, the first interstellar object ever detected passing by. Unlike typical comets, it had no clear tail, and its shape and motion defied easy explanation. Some speculated it was a shard of a shattered planet. Others whispered that it could even be artificial, perhaps a probe or fragment of technology from a distant civilization. While those ideas remain controversial, what Oumuamua and 3I proved beyond doubt is that our solar system is not isolated. It is part of a vast galactic network through which ancient wanderers constantly pass. The unsettling question is, how many of these travelers have slipped by undetected? Our telescopes have only recently become sensitive enough to notice them. For every one we catch, there may be thousands or millions more drifting silently past. Each older than our world, each carrying secrets we may never know. They are reminders that the universe is ancient beyond comprehension, and that Earth is a newcomer in a much older story. To us, 4 billion years feels like an eternity. To the galaxy, it is just a chapter. The presence of these wanderers also raises haunting possibilities about the spread of life. If fragments of ancient systems can drift across interstellar space for billions of years, could they carry more than just dust and ice? Could they carry the seeds of biology, amino acids, or even frozen microbes waiting to crash down onto fertile worlds? This idea, known as panspermia, suggests that life may not have started independently on Earth, but may have arrived here on the back of such cosmic messenger. If true, then life is not confined to single planets, but is a galactic traveler, carried from system to system, spreading across the stars on ancient wanderers like 3i. In that sense, we are not just children of Earth, but children of the cosmos itself. But even beyond biology, these objects force us to consider what civilizations might leave behind. If an advanced culture once thrived in a system billions of years ago, would its remains be scattered as debris when its star died? Could fragments of alien technology buried in rubble survive the long journey through space? The idea may sound far-fetched, but think of our own world. If Earth were destroyed, our satellite, spacecraft and technology could drift for millions or even billions of years to another civilization. Finding one of those fragments would be a revelation. Could we in turn someday stumble upon such relics hidden inside the wanderers that pass through our solar system? For now, we have no proof, but the thought lingers every time a new interstellar visitor is detected. What exactly are they carrying? What makes 3i even more mysterious is the way it broke apart as it passed through our solar system. Instead of staying intact, it crumbled into pieces, scattering debris like a comet disintegrating near the sun. Some scientists argue this was expected after all. Billions of years drifting through radiation and cosmic collisions would weaken even the toughest rock. Others wonder if the breakup hints at something deeper, a strange composition or structure we don't yet understand. The fragments quickly faded, leaving us only a brief glimpse, like a ghost vanishing into the night. We may never know the full story of 3i, but even that glimpse was enough to remind us of the scale of cosmic time and the fleeting nature of our place in it. In a way, these wanderers are the true storytellers of the galaxy. Stars die and vanish, planets form and crumble, civilizations rise and fall, but these fragments endure, passing silently between systems, carrying with them the fingerprints of forgotten worlds. They are the evidence that the universe has a memory far longer than ours. And that memory is written not in books or monuments, but in rock, ice and dust, drifting endlessly through the dark. To look at them is to realize how small we are, how brief our existence, and how much of the universe's story remains hidden from us. The haunting truth is that the galaxy may be filled with such travelers. At any moment, another one could be heading our way, a fragment older than Earth itself, carrying clues to worlds that existed before our sun was even born. We may catch it with our telescopes. We may even one day send missions to intercept such objects, to drill into them, to analyze their chemistry, to see firsthand what a billion-year-old time capsule contains. In doing so, we would not just be studying a rock, we would be touching the remains of a world that lived and died before ours began. We would be making contact, not with aliens, but with the universe's deepest memory. For now, 3i is gone, a ghost that slipped through our skies and left only questions. But its message lingers. We are latecomers to an ancient cosmos, one that has seen civilizations of stars and planets rise and fall long before us. The wanderers that pass through are reminders of those forgotten ages, hints that the universe is older, stranger, and more layered than we ever imagined. And the most unsettling thought of all is this: if such fragments survive the deaths of stars, then what might survive the death of our own world? What stories will Earth's ruins carry into the galaxy, drifting for billions of years after we are gone? Perhaps one day another civilization will look upon them and wonder, as we do now, who were they, and what secrets did they leave behind? When most people imagine galaxies, they picture elegant spirals like our Milky Way, serene structures of stars, slowly rotating around a glowing core. Textbooks describe them as majestic but stable, cosmic cities where stars are born, live, and die across billions of years. But the reality revealed by modern telescopes is far darker. Galaxies are not peaceful. They are battlegrounds. They collide, cannibalize one another, and sometimes rip themselves apart in displays of violence. So extreme they make supernovas look small. And one of the most haunting examples is a system that astronomers call the cosmic owl. At first glance, it looks like a pair of glowing eyes staring back at us from the void. But on closer inspection, those eyes are actually the dying remains of a galaxy being shredded into something unrecognizable. Its stars and gas pulled into long glowing tendrils that stretch across hundreds of thousands of light years. The cosmic owl is what scientists classify as a jellyfish galaxy. These rare structures are created when a galaxy drifts into the dense environment of a galaxy cluster, where invisible forces like gravity and radiation tear at it from all sides. As the galaxy plunges through the cluster, streams of gas are ripped from its body, trailing behind like tentacles. These tentacles glow with the light of newly born stars, creating surreal shapes that resemble cosmic sea creatures adrift in a black ocean. To us, they may look beautiful, but to the galaxy itself, it is a death sentence. Stripped of its gas, it loses the ability to form new stars, and over time it will fade into a lifeless shell. What we are witnessing is not a thriving galaxy, but the slow process of galactic suffocation. The violence of this process is staggering. Imagine a city where every building is pulled from its foundation and hurled into the sky, all while new structures ignite in the debris. That is what happens in a jellyfish galaxy. Stars are born in the chaos of destruction, only to be flung outward into the void. Whole systems may be ejected into intergalactic space, becoming orphans with no home. Some of those stars may even carry planets with them, planets suddenly exiled from their parent galaxy, cast adrift in eternal darkness. These rogue systems remind us that even galaxies, the largest structures held together by gravity, are not safe in the universe. What makes the cosmic owl so unsettling is how familiar it seems at first glance. From a distance, its two glowing eyes resemble a calm, watchful face, almost playful in its appearance. But behind the illusion is a story of unimaginable violence. The glowing circles are not eyes, but gaping wounds where matter has been torn away. The faint streams trailing behind are not feathers or wings, but entrails of gas being ripped from the galaxy's core. What looks like symmetry is actually destruction, frozen in time. It is a reminder that in the cosmos, appearances can deceive, beauty often hides violence, and order often conceals chaos. For astronomers, galaxies like these are more than curiosities. They are windows into the life cycle of the universe. Galaxies are not eternal. They are born from clouds of gas. They evolve and eventually they die, either by exhausting their fuel or by being consumed in collisions. The cosmic owl shows us one way a galaxy can meet its end, not by fading quietly, but by being torn apart piece by piece. And this is not rare. In fact, galactic collisions are common. Our own Milky Way is on a collision course with the Andromeda Galaxy, and in about 4 billion years, the two will merge in a violent dance that will reshape them into a new structure. For now, we live in the illusion of stability, but the fate of galaxies everywhere is to fight, collide, and die. This violence also plays a role in creation. The tendrils of jellyfish galaxies are not just streams of gas. They are cradles of starbirth. As the gas is stripped away, it compresses, sparking new stars in places where none should exist. In a sense, the galaxy is dying and giving birth at the same time, a paradox of cosmic proportions. Life emerges in the middle of destruction, a reminder that in the universe, endings are never final. The death of one structure is the birth of another. To see galaxies as peaceful islands is to misunderstand their true nature. They are dynamic, chaotic, and endlessly transforming. Yet the strangest mystery is why the universe seems to favor violence on every scale. From atoms smashing in stellar cores to galaxies shredding each other apart, destruction seems woven into the fabric of creation. Why must beauty emerge from chaos? Why must galaxies tear themselves apart to produce new stars? Perhaps the answer is that the universe is not designed for comfort or permanence. It is designed for change, and change at its core is often violent. For humanity, these discoveries raise uncomfortable questions. If galaxies themselves are impermanent, then what does that say about us? We often imagine civilization as fragile compared to stars and galaxies, but in reality, even galaxies can be destroyed. Nothing in the cosmos lasts forever. Not planets, not stars, not even the grand spirals of starlight we once thought eternal. Everything is temporary, and the violence of the universe ensures that nothing remains unchanged. To look at the cosmic owl is to glimpse our own distant fate, a reminder that even the largest structures can be undone, reduced to fragments drifting in the void. At the same time, the owl galaxy is strangely comforting. In its glowing tendrils, we see proof that endings are not empty. Stars continue to be born, light continues to shine, even as the galaxy itself disintegrates. Perhaps that is the real lesson of galaxies tearing themselves apart. Destruction is not the opposite of creation. It is part of the same process. One cannot exist without the other. From the ashes of collapsed systems, new stars rise, new planets form, and perhaps even new civilizations emerge. The universe does not cling to permanence. It thrives on reinvention. And so, when we peer at the cosmic owl through the eyes of the Webb telescope, we are not just looking at a galaxy's death. we are looking at the universe's endless cycle of transformation. To us, it may look like violence, chaos, and loss, but to the cosmos, it is simply growth in its rawest form. The owl stares back at us as a silent reminder that nothing is safe, nothing is stable, and nothing is final. Galaxies fall apart, stars collapse, and even Earth itself will one day be unrecognizable. But in that destruction, something new always emerges. When we think about the birth of stars, the common image is one of simplicity. A collapsing cloud of gas ignites under the weight of gravity, sparking a newborn sun that slowly stabilizes. Around it, disks of dust and ice swirl, eventually clumping into planets. It's a neat picture, one that has been repeated in classrooms and documentaries for decades. But the James Webb Space Telescope has forced us to reconsider that narrative. What it has revealed is not a quiet, predictable process, but a chemical frenzy, a storm of creation happening far faster and in far stranger ways than anyone expected. In the hearts of young stars, Webb has uncovered elements and compounds that should not exist yet, or at least not so early. Carbon, nitrogen, and oxygen, elements considered essential for life, are appearing in abundance long before traditional models say they should. In short, the universe is producing the ingredients for life much earlier, much faster, and in much stranger ways than science once believed. This discovery is a game changer. For decades, astrophysicists assumed that the early universe was chemically poor. The first stars contained mostly hydrogen and helium, the simplest elements forged in the Big Bang. Heavier elements, carbon, oxygen, nitrogen, iron, were thought to arrive later, created in the hearts of massive stars and spread through supernova explosions. According to that model, galaxies had to go through several generations of stars before life-friendly chemistry became common. It suggested a universe where habitable planets, and therefore life, would take billions of years to emerge. Yet Webb's observations show something radically different. Even in the earliest galaxies, young stars are already enriched with heavy elements. The cosmic kitchen is working faster than we imagined, whipping up the raw materials of biology long before Earth was ever conceived. The implications are staggering. If carbon, nitrogen, and oxygen were available far earlier, then the universe might have been ready for life much sooner than we thought. Civilizations may not just be possible now, they could have been possible billions of years before us. Imagine entire star systems where life began eons ago, civilizations rising and falling before our sun was even born. The unsettling truth is that we may be latecomers to the party, arriving in a universe where life has already had countless chances to thrive, evolve, and perhaps even vanish. What's more, the way these young stars produce heavy elements doesn't follow the clean, step-by-step process our textbooks describe. Instead, Webb shows chaotic bursts, as if the universe is improvising. Some stars show unexpected spikes in carbon-rich chemistry, while others reveal nitrogen compounds far in excess of what models predict. In some regions, oxygen appears in strange ratios, suggesting processes we don't yet understand. It's as if the cosmos has hidden recipes, shortcuts to creating complexity faster than we ever realized. And if those recipes exist, then the conditions for life may be baked into the very fabric of the universe. Life may not be a rare accident, it may be an inevitable consequence of the way stars burn. These findings also force us to reconsider the uniqueness of Earth. For so long, Earth has been framed as the rare jewel, lucky enough to form in a chemically rich environment at just the right time. But if heavy elements were abundant billions of years earlier than expected, then Earth is not rare at all. It's one of many outcomes in a universe overflowing with possibility. There may be countless Earth-like worlds orbiting young stars already seeded with the chemistry needed for oceans, atmospheres, and perhaps life itself. Instead of being exceptional, Earth may be ordinary, a single thread in a much larger cosmic tapestry. And yet, there's another side to this revelation, one that is darker and more humbling. If the universe has been ready for life for billions of years, then where is everyone? This question, often called the Fermi paradox, becomes even more pressing in light of Webb's discoveries. If civilizations could have arisen long before us, why don't we see their signs? Where are the beacons, the artifacts, the interstellar travelers? The silence of the cosmos becomes more unsettling when you realize life had so much more time to emerge. Perhaps civilizations are fragile, rising quickly and collapsing just as quickly. Perhaps the universe is filled with graveyards of once thriving species, erased by cosmic violence or their own mistake. In that case, the chemistry Webb has uncovered is not just a promise of life, it's a reminder of how fleeting life may be. The hidden chemistry of young stars also challenges our understanding of time itself. For decades we comforted ourselves with the idea that life needed billions of years to evolve complexity, that humanity's rise was the product of patience and stability. But what if the universe doesn't wait? What if complexity can emerge in a fraction of that time, under conditions we don't yet understand? If so, then life may not just be common, it may be quick, springing into existence wherever the chemistry allows. And if that's true, then the question shifts from is life out there to why haven't we seen it yet? The silence becomes more mysterious the more fertile the universe appears. Another startling implication is that life may not look like us at all. If the universe is experimenting with chemistry in ways we don't predict, then the biology that emerges may follow paths we can't imagine. Life may not require water, oxygen, or even carbon as we know it. It may arise from chemistries we consider toxic, environments we consider uninhabitable. On Earth, extremophiles thrive in boiling acid pools, beneath crushing ocean depths. Even inside nuclear reactors, if life can adapt so wildly here, then with the hidden recipes of young stars, it could evolve into forms far beyond our imagination elsewhere. To insist that life must look like Earth life may be the greatest blind spot of all. In the end, the hidden chemistry of young stars forces us to abandon the comforting idea of a universe that moves slowly and predictably. Instead, it is a universe of shortcuts and surprises, one that creates complexity wherever it can, as fast as it can. It tells us that the conditions for life are not rare, they are woven into the earliest chapters of cosmic history, and that realization is both thrilling and terrifying. It means the universe is not empty, but filled with potential. It means life may be inevitable, but civilizations may be fleeting, and it means that our search for answers is only just beginning. Perhaps the most haunting thought is this: if the universe has been ready for life for billions of years longer than we believed, then we may already be living in its aftermath. Civilizations could have risen, expanded, and vanished long before humanity appeared, leaving behind only fragments we don't yet recognize. We may not be pioneers at all, we may be inheritors, late arrivals in a cosmos that has seen countless stories before ours. The chemistry of young stars is not just a scientific revelation, it is a reminder that the universe is older, faster, and far more alive than we ever dared to imagine. For most of human history, we imagined planets as either barren rocks like the Moon, or gas giants like Jupiter, cloaked in thick atmospheres far beyond our reach. The idea that alien worlds might have atmospheres as complex and dynamic as Earth seemed like science fiction. But in recent years, the James Webb Space Telescope and other advanced instruments have shattered those assumptions, revealing atmospheres so strange, so contradictory, and so impossible that they defy the very rules we thought governed planetary survival. These are not minor mysteries, they are worlds that seem to exist in open defiance of astrophysics, holding on to fragile gases in environments where every law of science suggests they should be stripped bare. The most unsettling examples are planets that burn hotter than molten metal yet still cling to atmospheric shrouds. Take the so-called lava worlds, planets so close to their stars that their surfaces are seas of liquid rock. These infernos glow like forge fires, with temperatures soaring into the thousands of degrees. Logic tells us no atmosphere could survive in such conditions. Stellar winds should strip them bare in a matter of days, boiling away molecules into space. And yet, observations show that many of these worlds do indeed possess atmospheres, not stable, Earth-like envelopes, but shifting, regenerating shells of vapor that constantly rise from their interiors. It is as if the planets themselves are breathing, exhaling minerals and gases into the void, only to lose them and exhale again. Their skies are not stable havens, but battlegrounds of creation and destruction, remade every moment. This process hints at a resilience in planetary atmospheres we never suspected. Far from being delicate layers that vanish under stress, they can be astonishingly durable, adapting to environments we once wrote off as impossible. Some planets even appear to create weather cycles from vaporized rock, producing clouds of silicate dust that rain molten glass. Imagine standing on a world where the skies glitter with storms of stone, where jagged shards fall like snow, but hot enough to sear flesh. These are not the atmospheres we once imagined. They are alien ecosystems of minerals, chemistry, and physics. alive in ways we can barely comprehend. Then there are the super puff planets, another class of atmospheric mystery. These are worlds as large as Jupiter, but with density so low they are compared to cotton candy. Their atmospheres balloon outward into massive diffuse clouds, so thin that if you tried to stand on their surfaces, you would fall through layers of gas with no solid ground beneath you. According to models, such bloated atmospheres should not last long. Radiation from their stars should strip them away quickly, yet they persist, hanging on against the odds. How do they resist collapse? Are there unknown mechanisms at work, forces that shield their fragile shells from destruction? Or are we simply catching them in a fleeting moment, doomed to vanish within a cosmic blink? Either way, their existence forces us to admit that atmospheres can be far more diverse than the tidy categories we once imagined. Even more baffling are planets with secondary atmospheres, worlds that lost their original gaseous blankets long ago but somehow rebuilt them. These atmospheres don't come from captured hydrogen or helium, as in gas giants, but from the planet's own interior. Volcanic activity, tectonic shifts, and deep chemical processes continually vent gases into the sky, creating entirely new atmospheres from scratch. In some cases, these atmospheres appear to stabilize, becoming permanent features. In others, they seem to exist in cycles, waxing and waning depending on geological activity. This raises a profound question. How many times can a planet reinvent itself? Could a world lose its air entirely, only to grow it back and start again? If so, then atmospheres are not simply inherited from birth. They are dynamic, evolving systems capable of rebirth even after catastrophe. The implications for life are staggering. On Earth, our atmosphere shields us from radiation, regulates climate, and provides the gases we breathe. Without it, we would not exist. But if planets can rebuild their atmospheres under conditions we once thought hopeless, then the chances for habitability skyrocket. A world scorched bare could, in time, breathe again. A planet shattered by cosmic catastrophe could regrow its sky, and in those reborn atmospheres, life might take hold or return after being nearly extinguished. Far from being fragile, life-supporting envelopes may be some of the universe's most stubborn survivors, and yet, the mysteries go deeper still. Some atmospheres show chemical signatures that defy easy explanation. Observations have revealed hints of exotic molecules, carbon monoxide in impossible ratios, traces of metals in gaseous form, even potential biosignatures that suggest processes we cannot yet confirm. In some cases, the data seems to hint at conditions we associate with biology on Earth, like methane or water vapor in unexpected quantities. Are these false positives mere quirks of chemistry, or are they whispers of alien processes, perhaps even alien life? The possibility is tantalizing, and Webb's observations are only beginning to scratch the surface. Every spectrum, every reading, brings new surprises, forcing scientists to rewrite their models yet again. These atmospheric enigmas also force us to confront the fragility of our own world. Earth's atmosphere feels permanent, but history shows it has changed dramatically over time. Billions of years ago, it was rich in carbon dioxide and methane, toxic to us but nurturing to the first microbes. Oxygen only appeared later, transforming the planet into the world we know today. If atmospheres can evolve so radically here, why not elsewhere? And if alien atmospheres are constantly changing, then snapshots from our telescopes may only tell part of the story. The world we dismiss as uninhabitable today might become fertile tomorrow, and one we call Earth-like today may descend into unlivable chaos in the future. The strangest part is how little we understand about the durability of these alien skies. For centuries, we assumed atmospheres were fragile, vulnerable to loss, and dependent on narrow conditions. Now we see that they can survive extremes of heat, pressure, and radiation, even regenerating themselves against the odds. This suggests that the rules we once trusted are complete, that planets have tricks we have not yet uncovered. Perhaps magnetic fields play a larger role than we thought. Perhaps unknown chemical feedback loops stabilize atmospheres in ways we cannot yet model. Or perhaps the universe simply allows for more variation than our imaginations dared to permit. Ultimately, these impossible atmospheric mysteries remind us that the universe is not bound by human logic. It produces worlds that make no sense to us, planets that should not survive but do, skies that should not exist but shimmer with alien storms. For scientists, this is both thrilling and frustrating. Every answer creates more questions, Every discovery reveals deeper ignorance, but for the rest of us it is a humbling reminder that Earth is not the measure of all things. Our atmosphere may feel unique, but in truth it is just one possibility among countless others. The cosmos is filled with skies stranger, harsher, and perhaps more enduring than our own. The next time you look up at Earth's blue dome, remember that somewhere out there, another world glows with clouds of molten glass, another breathes out vapor from its fiery core, and another drifts with an atmosphere as thin and fragile as a soap bubble, yet somehow refuses to burst. These are not fantasies, they are realities, already observed. And if atmospheres can defy the rules so thoroughly, then what else in the universe is waiting to overturn everything we thought we knew? The mystery is far from solved. In fact, it has only just begun. One of the strangest mysteries uncovered by the James Webb Space Telescope didn't come in the form of dazzling galaxies or fiery exoplanets, but in something much smaller, quieter, and yet far more haunting: tiny red specks scattered across the early universe. At first glance, they don't look like much. In images filled with brilliant galaxies, glowing nebulae, and swirling clusters, these faint dots almost disappear into the background. But the more astronomers studied them, the more they realized these weren't ordinary stars or galaxies. They were something else entirely: compact, impossibly bright objects that didn't fit into any known category. And there weren't just a handful of them. Webb revealed over 300 of these mysterious red dots, each one a riddle that could rewrite our understanding of how the universe evolved. The first thing that made them stand out was their age. The light from these objects had traveled for over 13 billion years, meaning we were seeing them as they existed not long after the Big Bang. At that point in cosmic history, galaxies were supposed to be small, dim, and chemically simple. The universe was still young, just beginning to form stars and gather matter into larger structures. But the red dots didn't match that description. They were compact but shockingly luminous, glowing with a brightness that seemed impossible for their size. According to the models, objects like these shouldn't even exist so soon after the dawn of time. And yet, there they were, scattered across Webb's deep fields like red embers glowing in the darkness. What are they? That's the question that has left astronomers baffled. One possibility is that they are extremely massive galaxies compressed into a surprisingly small volume. If that's true, it means galaxies were forming far earlier and far faster than theory allows, condensing stars, gas, and dust into dense, blazing structures in record time. But if they are galaxies, their mass and brightness make no sense. Some appear as massive as the Milky Way, yet they existed just a few 100 million years after the Big Bang, billions of years earlier than expected. That would mean the universe built fully formed galaxies almost immediately, an idea that would overturn decades of cosmology. Another possibility is that they are not galaxies at all, but something stranger: supermassive black holes shrouded in gas and dust, feeding at incredible rates. As black holes devour matter, they produce enormous amounts of energy, often outshining entire galaxies. If the red dots are black holes, it would suggest that these monsters formed shockingly early in the universe, growing to colossal sizes far faster than anyone thought possible. But that raises another question: how could black holes so massive exist so soon after the universe began? The timeline doesn't add up. We're left with the unsettling idea that either our models of galaxy formation are flawed, or there are hidden mechanisms creating black holes at breakneck speeds. There's also a third possibility, one that pushes the imagination further. Perhaps these objects are something entirely new, a category of cosmic structure we have never seen before. The universe has a way of surprising us, producing phenomena that force us to abandon old assumptions. Quasars, pulsars, and even dark matter were once unthinkable until evidence made them undeniable. The red dots may be the latest example, a sign that we have not yet begun to grasp the full diversity of what the cosmos can create. What makes this mystery so gripping is how much it challenges our sense of cosmic history. If galaxies and black holes were already massive and luminous so early on, then the universe must have been far more active in its infancy than we ever believed. The first billion years after the Big Bang may not have been a quiet age of gradual growth, but a period of furious creation, with structures springing up almost instantly. That would mean the timeline of cosmic evolution is all wrong. Everything from the formation of galaxies to the birth of stars and even the conditions for life may have happened far sooner than we thought. The red dots also reignite one of the most haunting questions in science. If the universe could produce galaxies or black holes so quickly, could it also have produced life far earlier? If planets formed in these dense, compact systems, could biology have emerged while Earth was still a barren ball of molten rock? The thought is staggering. Civilizations may not just predate humanity by a few centuries or millennia, they could predate our planet itself. The universe may be littered with ancient histories, civilizations that rose and fell long before the sun ever lit up the sky. The red dots, then, may be more than just cosmic curiosities. They may be signposts pointing to an older, more fertile universe than we ever imagined. But the mystery also grows deeper when we consider their sheer number. Over 300 have been identified so far, and that's just in the small patches of sky Webb has observed. If so many exist in such limited views, how many more are scattered across the entire cosmos? Thousands? Million? Their abundance suggests that they are not rare anomalies, but a fundamental feature of the early universe. That means whatever they are, galaxies, black holes, or something new, they are central to the story of cosmic evolution. Ignoring them is not an option. To understand them is to understand how the universe became what it is today. And yet, for all the data, we are left in the dark. Are they galaxies burning too brightly, black holes growing too quickly, or something else entirely? Each possibility carries profound consequences. If they are galaxies, our models of structure formation collapse. If they are black holes, our theories of gravity and matter under extreme conditions must be rethought. If they are something new, then we are standing on the edge of a discovery that could redefine cosmology. In all cases, the universe is telling us that our understanding is incomplete, that we are still children staring into the night sky without grasping what we see. Perhaps the most haunting part of the mystery is the color itself. The redness of these dots comes from the extreme stretching of light by the universe's expansion, a signal of both their distance and their age. They are red because they are ancient, red because their light has been traveling to us since nearly the beginning of time. To look at them is to peer across billions of years, to glimpse the universe in its infancy. And yet even in that early light, we see objects too bright, too massive, too inexplicable to fit into our story. The cosmos is holding secrets in plain sight, daring us to uncover them. The 300 mysterious red dots are not just astronomical curiosities, they are cracks in the foundation of our understanding. They whisper of galaxies born too soon, black holes grown too fast, or cosmic phenomena we haven't even begun to name. They remind us that the universe is not a solved puzzle, but a living enigma, one that constantly outpaces our theories, and they force us to ask the most unsettling question of all. If we are already finding contradictions this enormous, what else are we missing? What other secrets wait in the deep fields, invisible until we build tools powerful enough to see them? Every strange discovery in the cosmos, whether it's a lava world clinging to its atmosphere, an ancient wanderer older than Earth itself, galaxies tearing themselves apart, or the hundreds of mysterious red dots glowing from the dawn of time, inevitably circles back to one question. What does this mean for Earth? For centuries, humanity has comforted itself with the belief that Earth is unique, a rare jewel among countless barren rocks, blessed with the perfect combination of chemistry, distance, and stability to foster life. It's an idea that flatters us, giving meaning to our place in the universe. But each new observation from the James Webb Space Telescope and other instruments challenges that comforting narrative. Instead of a universe where Earth is special, we see a universe overflowing with possibility, where the very conditions we thought rare may be common, and where the story of our planet is not the rule but the exception. The first implication is obvious. If the universe is capable of producing so many bizarre and extreme worlds, then Earth's stability is not guaranteed. Our planet has always seemed safe, tucked into the Goldilocks zone with a protective atmosphere and a reliable star, but planets like 555 Cancri show how fragile those conditions truly are. That world may once have been Earth-like, with oceans and continents, before migrating too close to its star and being transformed into a molten inferno. If such a fate can befall another planet, what protects us from similar shifts? Earth orbits a stable star now, but stars change over time. Our sun will expand into a red giant one day, boiling our oceans and stripping our sky, and before that, even smaller shifts, like solar flares, asteroid impacts, or shifts in Earth's own magnetic field, could threaten the balance we take for granted. The universe teaches us that planetary habitability is not a permanent gift. It is a temporary balance, and Earth is no exception. But the second implication is even more profound. Life may not require Earth-like conditions at all. For decades we searched for twins of Earth, planets with water, oxygen, and moderate temperatures. But the atmospheres of alien worlds show us that life might thrive in environments we once dismissed as impossible. If planets can rebuild their atmospheres after catastrophic loss, then life may have multiple chances to take root. If heavy elements like carbon and oxygen were abundant earlier than expected, then life may have arisen billions of years before Earth even existed. And if atmospheres can survive in places hot enough to rain molten glass, then perhaps biology can adapt to extremes we cannot yet imagine. In that sense, Earth is not unique. It is simply one variation among countless forms the universe experiments with. Our oceans, our skies, our breathable air may not be the only recipe for life, just one of many. This realization cuts both ways. On one hand, it makes life in the universe seem more likely. If the chemistry of stars and planets is richer and faster than expected, then the cosmos may be teeming with habitable environments. The mysterious red dots, whether galaxies or black holes, suggest a universe that was fertile for complexity almost immediately. Civilizations may not be rare, they may be inevitable. On the other hand, it also forces us to confront the possibility that Earth's exact form of life, water-based, oxygen-breathing, carbon-dependent, might be far rarer than we think. The galaxy may swarm with life, but life so alien we wouldn't even recognize it if we saw it. We may be surrounded but blind. There is also a sobering warning in these discoveries. If the universe can create galaxies, black holes, and planets at impossible speeds, then it can also destroy them just as quickly. The jellyfish galaxies remind us that even massive structures can be stripped apart, their stars flung into the void. The ancient wanderers, like 3i remind us that entire systems can die, leaving only fragments drifting in the dark. Earth is not immune to these forces. Asteroid impacts, gamma-ray bursts, or even shifts in galactic environments could wipe out life here in an instant. To believe Earth is safe forever is to ignore the violence written into the cosmos. Our world survives not because it is protected, but because it has been lucky. Luck, as history shows, does not last forever. And yet there is something inspiring in these lessons. If planets can cling to atmospheres against impossible odds, if galaxies can give birth to stars even while being torn apart, if fragments of ancient systems can drift for billions of years and still endure, then resilience is woven into the fabric of the universe. Earth too has proven resilient. Life here has survived asteroid strikes, ice ages, and mass extinctions. It has reinvented itself time and again, finding ways to thrive in conditions that seemed hopeless. Perhaps that is the true message for Earth, not that we are unique, but that survival is universal. The cosmos is not gentle, but it is fertile, and in its endless experiments, life continues to emerge. So what does this mean for us right now? It means we must rethink how we search for life. Instead of limiting ourselves to Earth-like worlds, we must expand our imaginations to include environments that look nothing like home. It means we must consider that civilizations may have risen and fallen long before us, their traces scattered across the galaxy. It means we must stop flattering ourselves with the idea of being central or special. Earth is not the pinnacle of creation. It is one story among billions, a fragile experiment in a universe that never stops experimenting. But perhaps the most humbling implication is that our time is temporary. Earth's habitability will not last forever. One day, our oceans will evaporate, our atmosphere will thin, and our world will join the countless others that once thrived and then perished. The universe does not grant permanence. What it grants is opportunity, time enough to rise, to explore, to leave behind something that endures. Whether humanity takes that opportunity or squanders it is up to us. The universe will continue with or without us. In the end, the strange discoveries of the cosmos are not just scientific curiosities, they are mirrors, showing us both the fragility and the resilience of our own world. They tell us that Earth is not unique, that life is both precious and common, that survival is always a struggle, and that nothing is guaranteed. To ignore those lessons is to gamble with our future. To embrace them is to understand our place, not as the center of the universe, but as one voice in a vast cosmic choir. And maybe, just maybe, if we listen closely, we can learn enough from those voices to ensure that Earth's song continues a little longer. In the end, All the mysteries of the universe, the molten lava worlds that rain shards of glass, the super-puff planets that float like cosmic balloons, the ancient wanderers that drift across time, the jellyfish galaxies torn apart yet still creating stars, and the hundreds of mysterious red dots glowing from the earliest dawn circle back to a truth that is both humbling and exhilarating. The cosmos is far stranger, far more violent, and far more creative than we ever imagined. For centuries, humanity placed Earth at the center of its story, clinging to the belief that our world was rare, protected, and uniquely blessed with the gift of life. But what the universe keeps showing us, again and again, is that Earth is not the rule. It is only one of many experiments in a cosmic laboratory that never stops working. The skies are filled with planets that challenge every law of physics we thought we understood, galaxies that form and collapse faster than models allow, and phenomena that refuse to fit into neat categories. Every time we look deeper, the universe pushes back, reminding us that our theories are temporary and that the truth is always larger than our imagination. For Earth, this realization is both a warning and a gift. A warning, because it reveals how fragile our stability really is. The balance of water, air, and distance that sustains us is not guaranteed, not eternal, but a fleeting arrangement that can be undone by time or chance. A gift, because it reveals how resilient the cosmos can be. Atmospheres rebuild themselves. Worlds find ways to adapt. Life, once sparked, refuses to surrender easily. And in that resilience lies hope, not just that we might endure on Earth, but that life in some form exists elsewhere, thriving under skies we cannot yet imagine. The more we discover, the clearer it becomes that the universe is not barren, but alive with possibility, overflowing with worlds that bend the rules, worlds that prove survival is not the exception but the pattern. What remains for us is to decide how to live with this knowledge. Do we cling to outdated beliefs of uniqueness, comforting ourselves with the illusion of permanence? Or do we embrace the reality that we are one chapter in a much larger story, a story that began long before us and will continue long after? The universe is not asking us to fear our place in it. It is inviting us to understand it, to look at the fragile blue sky above Earth and know it is temporary, but also to look outward and realize that fragility is not weakness. It is the spark that drives adaptation, the reason life fights so hard to endure. If we learn anything from the impossible atmospheres, the ancient travelers, and the mysterious red dots, it should be this: survival in the cosmos is never guaranteed, but it is always possible. So when we ask what all these discoveries mean for us, the answer is clear. They mean we are not alone in the struggle. They mean our world is not isolated, but connected to a universe that has been creating, destroying, and recreating for billions of years. They mean that Earth is precious, not because it is unique, but because it is part of something far greater. And if we take that lesson seriously, perhaps we will treat our fragile home with the reverence it deserves, while also daring to look beyond it. Because the truth is, the universe will keep rewriting its story, with or without us. The only question is whether we will choose to be part of that story, explorers who embrace the unknown, or a forgotten echo that clung to false certainty until it vanished.